welcome back to my channel, The Math Professor. Today we are discussing a very important topic, the Wavy Curve Method. And we will learn this method step by step using an example. And the question that we are using for the example is f of x equals x minus 1 whole cube times x plus 2 raised to the power 4, x minus 3 raised to the power 5, times x plus 6 divided by x squared times x minus 7 whole cube. And we will solve this for f of x greater than 0, greater than equal to 0, less than 0, and less than equal to 0. Let's first talk about the Wavy Curve Method and where to apply it. The Wavy Curve Method can be applied to any inequality of the form x minus a1 raised to the power n1, x minus a2 raised to the power n2, and so on, divided by x minus b1 raised to the power m1, x minus b2 raised to the power m2, and so on, where the inequality is greater than 0, less than 0, greater than equal to 0, or less than equal to 0. The condition is the right-hand side should be set as 0, and where all the powers are natural numbers, a1, a2, and so on, b1, b2, and so on, they can be any real numbers. Now let's dive into the explanation part. First, whenever you're given with any inequality and you want to solve it, the first thing is you find out the zeros and the points of discontinuity for that inequality. To find all the zeros, we set each term in the numerator equals 0. So we set x minus 1 equals 0, which gives us x as 1. Similarly, x plus 2 equals 0 gives us x equals minus 2. X minus 3 equals 0 gives us x equal to 3. And x plus 6 equals 0 gives us x equal to minus 6. And for all the terms in the denominator, they cannot be 0. So we'll say x squared is not equal to 0. That means x is not equal to 0. And x minus 7 is not equal to 0. That means x is not equal to 7. So we have found all the zeros and the points of discontinuity. All the zeros are 1, minus 2, 3, and minus 6. The points of discontinuity are 0 and 7. Next, we will mark all the zeros and the points of discontinuity on the number line. So minus 6, minus 2, 0, 1, 3, and 7. Now here we start with some rules. Rule number 1 is to mark all zeros with inked circles. So the zeros were minus 6, minus 2, 1, and 3. Rule number 2 is to mark all the points of discontinuity with open circles, or I can say uninked circles. So we have marked all the zeros with inked circles, and we have marked the points of discontinuity with uninked circles. Rule number 3 is to check the value of the function for any real number greater than the rightmost number on the number line. So the rightmost number on the number line is 7. So you can use any number greater than 7 in the function and check its value. So we can choose 8. If I choose 8, we will get 7 cubed times 10 raised to the power 4 times 5 raised to the power 5 times 14 divided by 8 squared times 1 cube, which is a positive number, so greater than 0. Rule number 4 is to start from right to left to draw a curve, which can be started from above or below the number line. And it depends on the answer that you get in step number 3. So in step number 3, if you get a positive answer, we will start drawing the curve from above the number line. And if you get a negative answer, you start from below the number line. In this case, we got the positive answer. So we will start from above the number line to draw a curve. But wait, we need to consider a few more points before we complete this curve. And those points are that the wavy curve should pass through all the zeros or the normal points, and it should remain on the same side of the number line while crossing through a double point. Now, what do we mean by a double point? A double point is obtained for any values of x where the power of that expression was even. For example, here the power is 4, which is an even number, and here the power is 2, which is an even number. For even powers, whatever values of x you get, those are your double points. So in this case, we have two double points. One is -2 and the other one is 0. So we got two double points and 4 simple points. While drawing the curve, we will pass through the simple points. At a double point, we will remain on the same side. So let's complete the curve. So starting from above the number line, we'll go through 7, and then we go through 3, and then we go through 1. And once we reach 0, because 0 is a double point, we will go to -2. Again, -2 is a double point, so we'll come back. And now -6 is a simple point, we'll pass through it. Giving you a recap, number 1, we found all the zeros. We found all the points of discontinuity. We marked all the points of discontinuity and zeros on the number line. All the zeros are marked with closed circles, or I can say inked circles, and then all the discontinuities are marked with open circles or uninked circles. In the next step, we choose a value greater than the rightmost point on the number line, and we substitute it in the function to find the value of the function if it is positive or negative. If the value is positive, we start drawing a curve from above the number line. If the value is negative, we start drawing the curve from below the number line. And the curve passes through the simple points, and whenever it reaches a double point, it stays on the same side of the number line. Next, whenever the curve is above the line, we mark that area as positive. And when it is below the number line, we mark that area as negative. So we have 3 positives and 4 negative areas. Now moving on to the next step to find where the function is positive, where it is positive or 0, where it is negative, or where it is negative at 0. It is very simple once you are done with the wavy curve, because it will give you all the positive intervals and all the negative intervals, and as well as it is giving you all the points wherever the function is 0. For number 1, we want to write all the intervals where the function is positive and not 0. So those intervals from the wavy curve are -∞ to -6, 1 to 3, and 7 to infinity. So we'll take union of these 3, and that will give you the answer for number 1. For number 2, we want to find out all the intervals where the function is positive or 0. So it will be somewhat similar to number 1. So it will be -∞ to -6, including 6, union number 2, because at 2 the function is 0, union 1, 3, including 1 and 3, union 7, infinity, but not including 7. So why not including 7? Because 7 is an open circle. It's a point of discontinuity. Moving on to number 3, we want to find out where the function is negative. So looking at the wavy curve, we can easily find out that the function is negative at -6, -2, union -2, 0, union 0, 1, union 3, 7. For number 4, we want to find out where the function is negative or 0. So it will be -6 to 0, where -6 is included, but 0 is not included because 0 is an open circle or point of discontinuity. Union 0, 1, including 1, and union 3, 7, where 3 is included, but 7 is not included because 7 is a point of discontinuity. And this is it for today's video. I'll see you in the next one.